So to start with, right? So you're gonna find all the stacks on the second link here. So you can just take a photo, or I think they can share the slides later. So a little bit about myself. So I started working on cloud since 2011. So I think at that time it's the time cloud really tried to take off. When I joined Oracle, that's actually my first job, and the cloud is really small in scope. At that time, there were only two services available. One is called Java as a service, and the other one is a database as a service. So I was sort of pretty lucky to be in this industry and see how cloud grows in the past 6-7 years. So I'm graduated from Cornell, so I love East Coast, to be honest, but I don't complain about the weather here because I like changing season, but sometimes just feel want to stay a little bit closer to snow, so I can do ski. So I'm a TPM right now, technical program manager. So I specifically running security and user trust program for the cloud. So I'm not sure if all of you are familiar with the terms like TPM, PGM. No? Okay. So a little bit of background. So I think at Google there are 3 different categories if you work on not technical stuff, but okay, anyway. So you're going to have a software engineer we call suite, and then you just building code. There are going to be a person in the middle called the technical program manager. So those people are actually working on processes, release, what kind of the feature we need to build, what is the priority, right? And then the next layer is the product manager, actually talking to customer, decide what to build. So if you think about the complete picture, so we have somebody as a product manager decide what to build, right? And then the TPM's technical program manager decide on schedules, what is the priority, so what kind of solution we need to use, right? So are we using let's just assume server client architecture or using some architecture, right? And then the engineers will be the one that decide, okay, I want to use this technology, I want to use this algorithm to solve this problem. So the program I'm running, for example, is let's say a very simplified example is say all the encryption algorithms using 128 bits. And then we decided, oh, this is wrong, so we need to have better security. So let's look at what is the viable solution, what is the best solution for Google. So then we decided, okay, we're going to use 256. So what is the risk of upgrading the whole Google, right, with that project, and how we can coordinate all the Google Cloud teams to deliver something at a the scheduled time. So before that, I was engineer at Oracle. So sort of I worked through my past, and I was an engineering manager 4 years later, 5. So I was leading 2 products. So my team actually built a load balancer as a service on the cloud. So that's from scratch. And also we worked on service deployment infrastructure. So which is actually the sort of we call it brain of the cloud. Just provision all the services. So when I just started, like I said earlier, we only provisioned 2 services, and at the time actually I switched to the new team. We already provisioned 70 services. So that's sort of how cloud growth in the past 5-6 years. Outside work, I like taking photos. I like travel. I do a little bit of machine learning project just for fun. All right. So a little bit of disclaimer before I really jump into the content. So everything I talk about is my personal view, so it doesn't reflect my employer. So it has nothing to do with Google. So even I say some bad word. So all the contents actually are public accessible. So I'm trying to get some of the data you're gonna actually be able to find on YouTube. And there are many white papers, documentations that are available. So I'm gonna point them out later, but they are all available, right? Okay, agenda today. So what is a cloud, and why cloud? And we're going to go through 2 case studies, and we also look at how big is the cloud today, and what is the things actually powering the cloud behind it. and what's the next step for the cloud. Okay, so I want to do a quick poll before I start it. So how many of you are students? Okay, can you raise your hand higher? Don't be shy. Okay. So then I assume the rest of them people are going to be like working for sometimes like have some working experience and looking for.
There's an unemployed here.
Okay. So I think at the beginning when I tried to schedule the talk, I thought it's going to be the major audience going to be students. So I will try to talk a little bit more on technical stuff, but I think at the beginning I was trying to put more data of how clouds looks like, a little bit business perspective and product perspective, just try to help people to get up to speed. So I can talk a little bit more on technicals. So, are you guys all looking for jobs in cloud domain? So, okay. So some people are nodding their head. Okay. All right. So, what is a cloud, right? This is actually, a quote I got from Amazon. I don't use Google because I think sometimes Google making things very complicated, right? So especially if you look at the definition on Google website, is very, very technical, and with the brackets that try to explain the definition. So cloud computing is on-demand delivery of compute power, blah blah blah. Resources over the platform, right? So they actually mentioned a few points here that I really like, right? So first is on-demand, right? Second is pay-as-you-go pricing. So I think that's sort of the first generation of how people look at cloud, because there are many other pricing strategy for cloud today. Like you can do subscriptions, and they're all kinds of tiered. You can make a commitment. So things are getting evolved a lot, and also. I don't actually find a definition for the whole cloud because if you Google it, so the most relevant definition you find is cloud computing, because I think that the word itself is a bit confusing sometimes, because when you think about computing, you think about compute powers, right? You think about machines. But today, what really is the cloud is a whole stack of applications. So this is an example of Google Cloud. Right? So I think when you think about cloud, we have a platform, right? So it has all the compute, storage, networking, all kinds of APIs. And then most importantly, right, people use Google Maps, use Google Drive, and Gmails. Those are really direct application built on top of a cloud. And then some of your stuff that running like in Android as like you can sync your contact between devices, right? If you use an iPhone, you have iCloud that you can, seamlessly syncing data. So those are part of the application of the cloud. So, the definition of the cloud actually involve quite a bit as well. Okay. So history of cloud. So actually, Salesforce started the cloud at the beginning. So they started delivering enterprise applications, right? Just like a simple website to start with, and Google is starting something, the cloud infrastructure, and the offer as a G Suite, which is the whole Google like Drive, Slides, Google Doc, that combinations in 2009. But the market doesn't react that well and called it like the cloud. So it's actually really the Amazon started the whole concept of cloud, right? So the problem with the standard, merchandise is they have peak time in their business, right? So think about people buying more stuff during Christmas, and people buy less stuff in say winter, right? So that poses a big problem for a lot of merchants, because they have to hold their website to serve the peak time, but in the non-peak time, all those compute resources are sort of sitting idle, wasted, and they have to pay a lot of, the electricity, power, cooling, depreciation. So sort of that's somebody come up with a great idea. Oh, let's rent it out, those resources. So that come with, the first, concept of infrastructure as a service. So people starting out to let people renting, compute powers. And today, we see three big players. So Amazon, Microsoft, and Google, right, in this territory. So Alibaba Cloud, Ali Cloud is number 4 globally. But Google actually is pretty late in the game, although we have so many fantastic technologies. So we are really trying to catch up the games. So just give you a little bit concept of the market. So Amazon is about 43% of the market share today. So, so Microsoft is 10%, and guess Google.
5.
Yeah. So Google is actually only 5%. So, but this is only for the infrastructure as a service, right? So if you're talking about SaaS applications, you're thinking about G Suite, right? The Google Documents, Slides, that's going to be much higher. But then if you think about Microsoft, right? Microsoft have like a 20 billion revenue, I think, on the Office 365, right? So there are different ways you can tell about the revenue, but just as for the infrastructure as a service, right? Like most of the developers that are interested in, so Google is trying to catch up in this game. So why cloud? So I think the first reason that I find cloud is amazing is allow developers to focus on product, right? So if you're thinking about startup, if you're thinking about different enterprises, so you don't actually have to run data centers, right? You don't have to care about how many machines you have to buy, how many users are going to use your services. So have to plan, enough time ahead so you can buy those equipments, right? Set them and maintain them. So I think that's allowed many startups to move really fast into into like a big enterprise, right? Like Airbnb, right? Airbnb is completely sitting on AWS today, right? And if you think about Snapchat is completely hosted on Google Cloud, right? So you only, as a developer, you only need to worry about how to make those products better. You don't have to worry about what the infrastructure looks like and all the logistics. The second one is scalability. So cloud has this on-demand feature, right? So one of the attributes. I have a case study that I can walk you through. Pokemon Go. So that's a really fun story. So to tell you how the cloud could auto scale and cheap. So pay as you go. When you don't use it, you just shut it down. So you don't have to manage IT. You don't have to manage data center. You don't have to worry a lot of security of your data center, etc. Right? Reliability. So I think Google Cloud is famous for its reliability, right? So it's not a secret, but whatever you store on Google, it's copied 3 times. So one copy going to be sitting in the same data center, but another copy is sitting in another data center. So it's really unlikely that your data going to be lost, right? So that's why a lot of customers actually choosing Google. So we have. That's also part of the DR, disaster recovery. Sorry about the acronyms. Also, you can have a lot of supports from communities and from we have on-call staff that can help a lot of customers as well. Security compliance, I think that's a big problem for the cloud. There are a lot of leaks of sensitive information on cloud recently. Including governments and military. So I mean, cloud is it's a sort of a top 3 differentiation features at Google Cloud, right? So minimum capacity planning. So I mentioned that when you try to launch some services, you really don't have to think about. You have to think about your worst case scenario. So I'm gonna highlight that in the case study. And 7's easy global expansion. So, think about, some apps that you build. You can easily have it deployed in other regions of the Earth, right? So it's going to be very easily to be accessed and serve the customer from a local data center, right? Instead of have all your customers coming to US and then coming back to China, say for example, right? So I think that's you know, there are going to be a lot of more reasons that why you choose cloud, but those are things that I find is most important, right? So case study, right? So Pokemon Go. So you guys have played Pokemon Go's, right? So have you experienced really bad problem at the beginning when you like you cannot properly log in, you cannot like the app doesn't the game doesn't work? No.
I think that's my phone problem.
Huh?
I thought that's because my phone is low end.
Oh, okay. So actually, what Google engineer found, right, is that so for all the big enterprises, Google actually work with the engineers of that company. So for Pokemon Go, before launch, we have a customer engineering team that work with the company, try to predict how many users they have. So I cannot disclose the exact number, but so the graph going to tell you basically, so the game company engineering told us, hey, we have 1x users. That's our expectation, right? So what is the worst scenario? So worst scenario is 5 times. So we're going to probably have 5 times of the user going to play the game, right? But in reality, like within 15 minutes of their game launch, you know, we've reached the expectation, right? And then the game actually grows to millions of users in weeks. So if you think about, you know, how things can grow, you don't actually. So I don't think like many apps or games going to grow that fast. When you talk about millions of users, that's typically like 6 months, right, or a year time frame. But it's going to be weeks right now at this speed. So what happened is, at the end, you require 50, right, x of the load of the compute power that you know, possibly could deliver. So that's why at the beginning there are some glitch. You know, to be completely honest, like some of the user experience that, oh, I cannot log in my game and take a really long time to load. So that's what happened. But I mean, if you take that as a worst scenario, like if you don't use cloud, what are you gonna do? You have to just buy all the machine on the market in Bay Area and then put in your offices. That won't work, right? So it's really, you know, the cloud could allow you to grow really, really fast, you know, potentially just overnight, right? So I think at the end of the day, they have thousands of like a Kubernetes, the container services nodes that are running in the cloud that, you know, serve all the game traffic. And I think the kind of the traffic today, you know, fluctuated a little bit, so we don't have that peak anymore. Then they can just gracefully shut down some of the instances to, you know, to save money, right? So next one, right? So Jungle Book. So you might think about, oh, how is the cloud, you know, connected with movies? So not sure how many of you actually do some 3D, you know, modeling and rendering. So it's like I in my college I take one class that is actually doing the 3D modeling, and then when you apply textures for the models, you have to calculate. And when you do a lighting, it will have to calculate how the lights bounce between all the objects, right? If you have multiple light source, then that can be, you know, millions of calculations, depends on how many times you want the light to be, you know, calculated. So in today's world, we want those movies to be as real as possible. So, you know, for one 64-core machine, right? So this laptop probably have 4 cores, right? So for 64-core machines, you need to take 24 to 48 hours to run one frame, to render one frame, which is like only 24, you know, 1 out of 24. So you need 8 million hours to render this the Jungle Book movie, right? So how could that possible, right? So you have to use cloud in order to scale horizontally, right? So then you can apply like a very powerful machine, but at the same time you can run it very effectively on Google Cloud with something called preemptible VM, which means you know, if you think about traditional compute node, you reserve that compute node, you own that, right, until you shut it down. So preemptible is something called, meaning that the company can guarantee you the machine exists for 24 hours. But gonna depends on the load. If there's no load, you're gonna continue using it. But there's a lot of customer requiring resources, then we're gonna shut it down, right? So, but of course there are some mechanisms we're gonna tell you before we shut it down. But then that's gonna greatly reduce the price of the compute power, so that they can run like thousands of cores at the same time when they start running in this video, right? Jungle Book in 2016. So 6-time reductions of the time versus on-prem data center, right? So if they have so today I think most of the Hollywood studios and all those big 6 studios in US, they are using primarily on-prem data center because most people care about security, right? So they don't want their unreleased film to be somehow leaked. So that's also like security thing. But see, the industry is actually taking actions to moving more sustainable way of running their business. So I want to show you this video really quick.
Thanks, Will.
So I only take this like probably 20 seconds of my colleague's presentation. Jeff, he's actually the media lead for Google Cloud. So I think this video is on the Google Cloud Next conference. So if you just go to YouTube and search for Next, you're gonna see a lot of very specific targeted videos about how Google Cloud solve a lot of problems for the customer. So very interesting to look at. So. I want to just bring up something here. Actually, a very interesting thing is Twitter. So I only put Twitter here is because the news announced last Friday. So Twitter actually moved 20% of their payload into Google Cloud. So that's public announcement. So they're also exploring different options because most of the big giant tech company today, they have their own data center, but company want to really move fast. Right, so if you don't actually the expertise of the cloud to run data center, so why not letting someone else to run it? So Spotify, Ubisoft, Evernote, many others. One thing I really like is Philips Hue. So Philips Hue is actually completely running on the Google Cloud. So anyone use Philips Hue here? No? Okay, one people.
Toothpaste?
What?
Like toothpaste?
No, so Philips Hue is a home automation light bulb. Right, so you can control your light. The hue, yeah. So you can control it using. Sorry, I said it wrong. Or?
No.
Okay.
I said which is Hue.
Oh, sorry.
So it's from Philips, right?
Yeah, Philips Hue. So they have probably millions of invocation every day, right? So that technology, I think, is built on App Engine on Google or Cloud Endpoint. I forgot. So actually, that's sort of the load the Google Cloud is empowering. Like many people just go home and click tap something on their phone, the light just light up. That's because at the back end, Google is powering it. So yeah, I mean, there are many interesting stories about cloud.
Why that bulb is most well known for working with Amazon? I mean AWS.
So their backend infrastructure is deployed on the Google Cloud, right? So when you actually for Philips Hue, you actually own a hub at your house. So what your app going to communicating is to your I think to the cloud, right? And then do some calculations, authenticate you, and then that image that signal going to transmit it to your hub, right? The hub going to control the lights.
Yeah.
So your question is why?
No, I'm very interested about this because people more know that Hue is working with AWS than Alexa, but
I got your point. Yeah.
Working with Google Home right now, but I mean Hue is at first, I mean, famous for working with AWS.
Right. So I think the AWS you are talking about is Alexa's,
Yeah,
right?
yeah.
So it's a voice assistant. So voice assistant is different from what is powering the backend of the services, right? So Alexa or Google Assistant or Siri is an invocation mechanism. You invoked your app, right? So your app is going to talk to a backend server, right? So the whole server in the infrastructure is on Google. That's what I'm saying. Yeah. Okay. So type of a cloud offering. So I think those terms are probably very common. So maybe you guys all know it. But as you quickly go through it, infrastructure as a service, right? So we have compute, storage, networking, and many others. Platform as a service. We have App Engine, and I put an Amazon name for it, the counterpart. So Elastic Benchstock, and there are many others. Like Java as a service, and say database as a service. Yeah, that's also a platform as a service. And the SaaS services. So Google Map, Gmail, YouTube that we just talked about, and also big, really giant enterprise application like customer relationship management. Human capital management. So like HCM is used. It's a common thing that used for all the companies that manage their headcounts. Employee. What's your payroll? What's your vacation, etc. Right. The CRM is more used for sales organization. So that's sort of I think the three big category. I mean, there are people inventing new terms, right? But I think underlying is going to just fall into one of those. Yep, so cloud solutions. So I think at the beginning, so he mentioned so some of the courses offering, right? So it's basically, if you have some use case, right, how you could use cloud solution, cloud technology to solve your particular problem. So I just put this graph here. So this is not an official Google recommendation, but so how if you build a mobile game today, right? So how is your architecture going to look like? So you have your devices here, and what endpoints, right? You're going to talk to. You're going to talk to say cloud endpoints, right? And then the cloud endpoints going to translate the API call into some App Engine backend, right? The App Engine backend is going to talk to the storage and batching processes to get images and all the user data. So if you think about how you're going to write code for a product today, it's going to be completely different because you don't have to think about how to build something like very detailed implementation for each of your thing. Instead, you already have all the building block, right? The building block in the cloud, and you only have to think through, so what is the best solution for building my product, and how things can fit into the picture and cost efficiently, and then also have a really good performance. Something I mentioned, BigQuery to query user data. Actually, this is another better example for IoT devices. For this, right? So let's say if you use an IoT device as your home. So I have Ecobee, so I'm not using Google products again. Ecobee is a thermostat that you can control, your heating and cooling in your house, right? So what it does is, it actually like a small device here, or the Philips Hue light bulb, right? And you're going to talk to some gateway at your home, and then the data is going to be ingested into the cloud, right? So the cloud is going to do all the processings and also, empower, the business owner to run a lot of analytics data, right? So like you're going to have millions of devices and billions of operations, and how you find intelligent data out of how customers use the devices, right? So there are going to be tons of ways to building, one product. So I think the goal here is not telling you, hey, this is the way to build IoT devices workflow, right? So this is just an example how you can use different building blocks within cloud to fulfill your requirements. Right. So move to the next thing. How big is the cloud? So this I won't let you guess, but I'm going to let you guess the next slide. So this actually is another differentiation of Google. So I was getting a little bit warned that people are going to ask me, oh, so how do you compare Google Cloud with Amazon, right? I think this is one of the differentiation thing because Google actually own networks. So you see all those lines are Google paved cables across the continent. So I think no other cloud providers actually doing that. What that means is actually Google have this private proprietary cables that run really, really fast. That data locality is not an issue anymore. So I think Google also is a big player in the hardware. So if you think about cloud, it's not just the product that I show you, right? It's everything actually empower it. So like there are a lot of hardware engineering team just try to improve, the output and throughput for network switch, right? So the breakthrough that Google did is called Jupyter Network Switch, right? That allowed Google to deliver 1 petabits per second, and that was like almost 100 times better than the traditional, the commercial hardware, right? It's the enterprise commercial hardware you can buy on the market. Google's is like 100 times better than that. So those things actually, empower this global networks that if you're a customer, say in Mumbai, and then you want to access it in Europe, they're going to be, probably just 1 digit of latency, which is not possible for, other cloud providers. So, I put up this slides just for, the purpose of, Google actually have a lot of a presence in many, many countries and continents, of course. So, the next one, actually, I want to ask you to take a guess is how much is the cloud revenue today? Let's say 2017. Like revenue in dollars. In dollar amount.
Billion.
Yeah, it's definitely billions. So all the cloud.
1,000 billion?
That's too much. So okay, it's what? It's about 400. Yeah, it's 400 billion.
Closer.
Well, take an average, so I'm in the middle. So it's a really, really big industry right now. So I think for the audience here, I think what you probably can get out of the room today is cloud is growing really fast. And I don't actually have Google data, so I use Amazon as well here. I don't think even we actually published it because I think Google is trying to catch up the game. So it's not showing up in the balance sheet, but I may be wrong. So Amazon actually growing like a double digit every quarter. So they have like a 5 billion per quarter, if you look at that for the Q4 last year, right? And then the growth is unstoppable. Yeah, so it's actually the same thing for Google, right? All of the cloud providers are growing really fast. So the reason behind it is the whole industry is actually going through this revolution, right? So if you think about Twitter today, Twitter migrated, and all the tech companies are migrated. But think about bigger pictures, like how traditional companies going to move to cloud. So that's going to be really, really massive. You can probably take an analogy of how computers get to each one's house, right? So we don't have that. It's super expensive. And then later on, how everyone can be able to afford a computer. It's the same trends happening here. And this is just a start, right? So the big companies are able to start investigating, they evaluate the risk, and then move to the cloud. And then the rest of the whole industry, healthcare, banking, government, they're all going to move to cloud. So there are tons of opportunities, happening in this industry, right? So what's behind the Google Cloud? So this is actually a funny thing because I think even before I look at some of those photos, I don't realize how fancy Google Data Center is. So this is one of the Google data center. This is in Iowa. So if you look at some of your YouTubes, you pull up a video, it's probably going to be served in one of those, the compute node. So actually, this is a project happened in 2011, I think. So it's really hard for even Googlers to get into one of the data center. So Google have this culture of be very transparent. So like we can walk to a lot of buildings and different projects, but data center sort of is this restricted area. So not a lot of people actually know what's happening. So next one is the rack of the compute node, right? So all the blinking lights gonna telling people, oh, here everything is running perfectly. Right? This is in Georgia, and I have another one. This is more googly, so all the Google colors. So this is actually a funny thing because it's actually a requirement for compliance that you have to label your water pipe in different color to separate what are they, right? So I would guess, I don't know, but red one may be hot water, right? And then really hot. So the blue one is cooling, right? So help to cool the data center. So, I mean, the reason actually I put this few photos is that, when we still talking about cloud, we're talking a lot on, customer-facing product. But what is really amazing behind Google Cloud is all the, hardwares. So all the firmwares, all the, data center operations, all the, networking cables that empower this. And, they are all part of Google Cloud. So like for myself, I like all the hardware stuff. So I have some, network attached server at home. So I run a NAS server. I have a home, like a dedicated server, a rack, like doing VPN stuff, right? And then I have like 15 terabytes of data, like running at home. I don't know why I use it, but I have some images. But so the point is, if you were really interested in certain part of the technology, right? So Google is actually a pretty good place to work at. Sorry, this is not an advertisement, but this is something I really figure out because I think this is a big difference compared to other cloud providers because Google culture is pretty technical and technology driven. So if you worked on certain things, you can find it in Google, and people try to do it, to be the best on earth. So I think that's a really powerful thing at Google. So a little bit on where cloud is going. So I sort of touched the point a little bit. Cloud becomes a commodity today. So I think for you guys here, you all know what cloud is, but when I talk to my mom, I used to talk to my mom said, hey, Baidu Yun. I said, no, that's not what cloud means, right? So many people think about cloud as just a storage, right? The cloud storage. But they're way more than just a storage, compute, and networking. It's all the apps, all the SaaS services, all the networks that, as a whole, that can, transform a lot of industries. So that's an ongoing trend, right? That's why I'm saying cloud is really disruptive technology. So, all the industry going to gradually move to cloud just because, the cost, right? And then security and the compliance and, the people's ability to focus on products because, if you write up like Snapchats, right? Why care about how to run data center? But this is ongoing, and people have concerns today, right? That's why we don't see cloud as that disruptive. That everyone just moved to cloud because for big enterprises it takes time. So third one, cloud is going serverless, right? That's another big direction that people is trying to do. So we just talking about compute node, storage, but toward the end, right? What developers want is I want to have a scalable system that can just take this API call, right? And then this API call can fight one time or 50 times, I don't care, just scale it. So that's a big direction we are seeing, like going serverless. Just Like, is that clear? Do you guys need me to explain a little bit on serverless? So there are actually two products, right? So in Google, it's called Cloud Endpoint. I think it's pretty close to Firebase, right? And then powered by Firebase. And then the other one in the Amazon is called Lambda, right? So basically, you defined your API, and then you write the logic in it, and you don't have to care anything about machines. You don't have to configure auto-scaling group. You don't have to, set those, auto-scaling policies. So I think that's the next step for how people scaling cloud. Fourth one, cloud grow with machine learning hands in hand, right? So I think a couple years back, people talk about big data, right? So now I think it's not that common anymore. But when we have big data problem, like we use Hadoop, we can solve it, which is, solve it in a very distributed way, which is actually, cloud is good at. But today we are going to be challenged with machine learning problems that you have millions of images, you have millions of data that you have to train, how you can train it effectively, right? So I think most of the driverless car company today, they either train their model on AWS or train it on Google Cloud. So Google Cloud actually is a big, differentiation. Like machine learning is a big differentiation for Google Cloud that survive in this competition. So this is growing pretty fast. But without cloud, people cannot train data, right? So you cannot have meaningful and useful models. So when people want to really get into the machine learning, you have to do it with a cloud, right? So I also put a environmental NGO there, the nonprofit. There are many stories about how people and researchers finding machine learning really helpful to, say, identify the species in the forests, right? To identify if the tree has certain diseases or not. So those giant amount of data was trained on the cloud. So just point that out. So why do I need cloud to know cloud, right? So this is why you guys are here. So it's a very good domain because in cloud today, right, we have probably 70 offerings, maybe too much, but that's around the time. So Amazon actually have a little bit more, right? So those are all very interesting product that you could work on. But when we talk about 70, those 70s are customer-facing product, right? So there are many things that actually happen behind those products, right? There are a lot of infrastructure work. There are networking, there are many other things you can really, try to improve and make the cloud better, right? So challenging work, and then there are a variety of positions, right? So if you really like doing coding, that's, the right place to be. You can do technical manager, program manager. You can do product manager. So you can probably figure out what's going to be the next step for the machine learning on cloud. Right? Last one, I think, is most important thing. Hiring is very, very aggressive. So I think this is applied for Google, Amazon, and Microsoft as well. So I think what? Yeah. So I think the company is trying to win this competitions, and it's too early to tell yet because though I shared the market size earlier, but it's really not a real indicator because AWS is have this, of course, first mover advantage that they started early, and Google definitely have a lot of strengths in AI machine learning, and this is actually the area that a lot of customers actually try to migrate. Right? And Microsoft is also good that in terms of the bundled solution they have Office 365 that they can easily build integrations with the cloud and other stuff. So I think each company have their own advantages, but I think all of them are hiring really, really aggressive. So what can I do with cloud? So I mentioned a little bit earlier. So I personally use Cloud for running some TensorFlow projects. Just for fun. So second is web hosting. So actually abandoned GoDaddy. I was a customer of GoDaddy. It's a hosting service, but I just figure out, hey, if I put my my website behind just on the Google Cloud, put it into the storage, save a lot of money. Actually, the other thing is a VPN server. So I actually run VPN servers for my parents, so they can, work through the firewalls and look at the information in US. So I actually hosted that in AWS a year ago. Then I was trying to say, hey, I'm going to join Google, so why don't I use Google? And I have that instance run for probably 2 days, and I get a notification saying, hey, you're running a really big instance, so you can downgrade it for saving like 30% of the cost. Say, hey, why not do it? Like I click the button, and then in runtime, that instance just shrinking down, so you don't have to, stop your services, right? So that's really seamless. Fourth one, I use the storage for a lot of my drone images. So I took a lot of images and terabytes of data. I just put it there, and backup. So of course, I use it for a lot of backups of my terabytes of data. So try something today. So I think. I only put 2 links here. Both Google and Amazon and Microsoft, all of them are offering $300 promotions. So if you just go to that whatever page and /free, right? So use your account, so you can have $300 for a year. So you can just use it for whatever you want. You can go and explore what are the functionalities. You can go and explore some of the exercise you can find online. So I think there are plenty of things you can try. There are tutorials online as well. And at the end, I just put all the resources, and there's some tech talks as well on the web page. So one thing I think you guys might find interesting is I think you all want to know more about, say, technical stuff or business stuff. So where you can find them. So I think Google Cloud has a pretty good resources. If you go to the cloud.google.com, so on the top, the navigation bar, there's a customer, and then there's a documentation. So if you're interested in how people using cloud, right, all the use cases, find products that you're interacting with, you can go to the customer and find the customer in the list, and then click the customer. You're going to see the use case. And then how they develop their solution on top of the cloud technology. So those are case studies. So if you go to the documentations, you can pick one of the product that you're interested in, and you will find white papers. You will find real signed papers as well, explaining all the technology behind it, right? So with that, I'm gonna just wrap up and then answer some questions.
因为我们今天主要讲的还是偏理论的内容嘛，大家有一个整体上的概念，是吧？但是如果你真正能在工作中熟练的应用这些技术的话，恐怕还是需要有一些实践的经验才可以。那所以在这个地方就给大家隆重的说一下我们的这个全镇开发项目实战班，给大家简单的介绍一下。对，然后这个班的主要目的是什么呢？其实主要也是结合我们之前很多同学，包括很多咨询的朋友，他们经常碰到的问题。我们知道现在技术的发展日新月异吧，这个招人的公司他们的要求也越来越高。非常希望大家即使是没有一定的工作经验的同学，之前也是至少会知道现在比较流行的一些技术。如果你有一些相关的一些 experience 的话，会对你整个的背景包括简历会有一个非常大的提升，也能够帮助你这个更多的拿到面试的机会，是吧？所以说我们针对这种情况吧，开设了这个项目班。所有项目班的老师也都是现在全都在我们的一线大公司工作的资深的工程师，然后也是经过了我们很长时间的 research 吧，然后结合了现在非常流行的一些技术的要点、一些主题，然后也是希望能够通过这种相对来说比较集中的这种授课的方式，交互式的授课方式，能够在相对来说短时间之内更好或者是极大的提升大家的这个技术方面的背景。 然后大家可以看到，这个我们在2个月之内会教5大项目，涵盖了现在所有的大公司。基本上你要做一个成熟产品的话，从前端到后端，大数据、云计算到移动开发，牵扯到的所有的这些技术的方面，以及也是参考了现在最主流的一些 product 这么一些主题吧，比如说推荐系统，然后包括 social network， 然后包括一些数据的处理，还有热点的搜索。然后我们上课的模式是这个理论加实践，然后这个实践是非常重要的，对吧？现场 debug， 然后你会有足够多的机会由这些资深的工程师来手把手的帮助你完成这些项目。这样子的话，你能够真正跟别人说你确实是有这些现在比较前沿的这些技术的背景。然后除此之外，我们这个课程还会有这个针对每个人的情况有个性化的针对简历的这个修改啊，包括去辅导大家怎么样能够在真正面试的时候充分的把自己的能力全都表现出来。然后再介绍一下我们的几个项目，比如说第一个，这基于 GeoIndex 的 Image Processing 短视频社交网络。应该我相信大部分人现在都在玩抖音吧，或者是 Snapchat 之类的，是不是？如果说如果你平时工作或者学习中没有这个机会真正想要了解一下，你比如说你作为一个 Snap Engineer 怎么去 build 这个整个的 product， 或者是抖音，基本上你可以想做一个相对来说比较完整的 prototype 的话，那这个是我们的拳头产品之一了。当然它的这个用到的技术，那现在是最流行的技术，包括在 Google Cloud 上面很多的板块，包括现在比较流行的 Go 语言，是吧？所以说这个是一个非常非常好的机会。然后第二个项目的话，主要是数据的分析和可视化。那这个其实现在所有的大公司基本上都在做，基于实时的，比如说 Uber 的 backend， 他们都需要实时的对于你现在 driver， 还有包括这些打车的人的各个区域的这些数据来进行分析。这样子的话可以更好的能够 target 到它的用户。所以这个是很多公司现在都比较流行的build 的这么一个东西吧。然后第三个也是一个比较大的比较复杂的这么一个系统，就是推荐系统了。那实际上现在所有的这些 IT 巨头公司吧，他们都是需要有一套非常高性能非常完整的这么一套推荐系统，这样子才能更好的 target 到用户。那这个系统本身是一个非常 full stack 的 project， 从前端到后端有很多的模块来组成，相对来说也是非常复杂的这么一个 project。如果你能够真正完成这个 project 的话，那基本上跟一个比如说大公司你做一个 internship 是没有什么太大区别的。所以这个是能够很好的提升你整个的背景。更重要的一点是你能够在真正工作之前吧，你就大概了解一下我将来的工作大概是什么样子的，有这个 sense， 你在面试的时候能够跟这个面试官有更多的共同语言。然后剩下的第四个就是基于云计算和大数据的用户分析了。那这个现在人工智能，然后包括数据分析肯定是现在的一个非常火的方向，也是基于这个需求吧，我们设计了这么一个 project， 在云平台上面你会有机会涉及到大量的数据，然后根据各种各样不同的 business case 来对这个数据来进行分析，然后最终能够做出一个非常完善的 business decision。然后第五个项目，这个也是现在比较缺人的一个方向，就是一个完整的 product 必须要包含一个非常好的、非常interactive user experience 非常好的这么一个前端。那现在最火的当然是移动端，对，所以说这个也是给大家介绍，就是现在比较流行的、比较新的移动端的这些技术应该怎么样去 build 出来一个大家都喜欢用的这么一个 product， 是吧？教学特点 ，OK， 好吧。对，我刚才已经说了，我们是这个交互式教学，并不是说你看个视频就完了，然后基本上老师在上课的时候都会手把手的跟你一起来 debug， 然后直到你把所有的内容全都自己能够 implement 为止。然后除此之外的话，就是在这个课程上面，我们不仅会讲这个 project 到底怎么去实现，它背后的一些原理，然后包括这几个方向将来对你的 career path 的发展到底有什么影响，我们在课上其实都会讲到。那这些也是你这个人整体的这个素质的非常重要的一部分。然后对于刚刚步入职场的同学来说吧，其实你的技术的深度和广度是同样重要的。这个到时候可以就是更多的能够帮助你增加你可能迈射到方向的这个可能性。那么这个也是我们课程一个非常重要的目标。我们不仅会讲精，也会讲深，从各个方面吧，能够从这个全方面的能够提升大家整体的这个能力。 然后最后就是我们有个性化的这个设置，在课程完毕之后的话，还会对大家进行1对1的简历的辅导，以及我们会进行这个针对面试的 mock interview 的指导，所以希望能够帮助大家在真正你去找工作之前能够完全的准备好。然后最后一点点时间，我们新的一期项目班开班的时间是5月9号的晚上7点，第一节试听课，第一节试听课是免费的，所以说有感兴趣的同学，或者说你知道你身边的朋友有感兴趣的朋友的话，希望大家能够传播这个信息，也能够帮助到更多的人，好吧？我的任务结束了，谢谢大家。